Hi everyone. In the last lecture we established that the electric field has no curl, has no circulation associated with it. And it's a mathematical consequence of this fact that a function exists as a function of space and time that can completely describe the electric field. This is very similar to what happened in the chapter on work and energy, where we talked about the fact that if a force is conservative, and what we mean by that is the fact that if you take a force all the way through a cyclical or a cycle, then the total amount of work that's consumed is regained on the trip back. And therefore, the total amount of work done in a closed loop is zero. The corresponding idea for an electric field is that the circulation is zero, and therefore an electric potential exists in parallel with the potential energy associated with the force. Now, if you remember, for every different force, there was a different kind of potential energy. And in the same way, for the electric field, there's a specific kind of potential. That potential is called voltage. And that is the voltage that we know and love when we plug in our electronics into the wall socket. Now, at a basic level, this is the definition of voltage right here. Voltage is defined for a particular point charge. And I don't remember if we talked about it at the time or not, but this is the same kind of formula that exists for gravitational potential. And that's because the fundamental force, the formula that drives the force, is the same between the two. Coulomb's law, Newton's law of gravity have the same kind of mathematical form. Therefore, their corresponding potential have a corresponding mathematical form. The bottom line here is that the potential due to a charge is directly proportional to the inverse of the distance away. And this Q represents the total charge that's emitting this potential field. And by far the overwhelming advantage, the reason we want to use the electric potential is that it's not a vector. This is the same that happened with energy. Whenever we could use energy in a mechanical problem, we used it because it's not a vector. We don't have to deal with all the trig. Same thing is going on here. So, because this potential exists, it really simplifies a lot of the problems that we're going to deal with throughout the rest of our dealings here. The connection between the two, voltage and the electric field, is given by this formula. This formula also should remind you of something from the chapter on energy. This is very similar to the definition of work, where you have force over a particular displacement. The work is the product of the two, in the same way that if the electric field is constant, then the total potential between 2 points is that electric field multiplied by the displacement, or the distance, between the two. Now here I've got the term average. That average is there just in case the electric field is changing. If the electric field is varying from point to point, then we need a little bit of calculus in order to calculate this average. Nonetheless, this equation still holds. So that's the connection between the two. One thing to point out here is that the voltage is only defined through its difference. This also is similar to energy in the fact that we don't really deal with energy per se, we don't deal with voltage per se, we deal with voltage differences. And so we say the voltage difference in this circuit is blah, blah, blah. The voltage difference here is blah, blah, blah. And that's a main thing to deal with when we talk about voltage differences. The last thing I want to point out here is the definition, the definition of the potential energy that is due to voltage. This really makes explicit the correspondence I've been emphasizing throughout this video, is that the energy is really, the force, if you remember, is the test charge multiplied by the electric field. Well, the potential energy is the test charge multiplied by the voltage, and that really boxes in our little correspondence here between all the various formula.